So let's write our reflexive ACLs on R1. Now in Notepad, I've listed out exactly what we're going to do. What we're going to do first is we're going to create our outbound named ACL. It needs to be an extended ACL. So you can see the commands here: IP access -list, an extended ACL, and then the name of the ACL, which will be outbound _ ACL. Then we're going to permit ICMP for ping from any source to any destination. We're also going to then permit TCP, any source, any destination, and notice we haven't specified a specific protocol, so we're not doing equal to 80. We're not going to do that. We're going to open up every TCP outbound service or port, right? But then we're going to use the reflect keyword to say, okay, we're permitting TCP from any source to any destination, but we're going to create a reflexive ACL named TCP-traffic so that on the return it'll be evaluated against this reflexive ACL so that only TCP traffic that's been initiated from inside the network will be allowed back through. And that's what this reflect keyword does in this ACL statement right here. So we use the reflect word, then the name of our reflexive ACL, which we're going to call TCP-traffic. Then we hit permit UDP. We're going to permit the UDP protocol, any source, any destination equal to 53, which is going to be for DNS. And then we'll reflect that. We'll call it DNS-traffic. And we're also going to put a timeout on it of 10 seconds. The default, I believe, is 300 seconds, and we're going to do a shorter timeout. So that's going to even shorten the window that the reflexive ACL has, the window of opening on the return traffic, right? So if DNS is not resolved within 10 seconds, that reflexive ACL on the return will be closed. Now that we have that set up, or now that we're going to set that up, we also need to have an inbound named ACL. It also has to be an extended ACL. We're going to call it inbound _ ACL. And you can see here, permit ICMP pings any source, any destination. Then to make this work, we use the evaluate statement, right? So evaluate, and then we tell it the reflexive ACL that we want to evaluate on. And this is on the outbound, right? So this is going to check the traffic to see if it was initiated from inside the network, and if it was, then it'll let it through for a limited time. Once we have our two ACLs written, we have to then apply them to interfaces or an interface on the router. One outbound, one inbound, and it'll be pretty easy. We'll go to interface serial 000, and we'll put IP access -group, and for the outbound ACL going out, and the inbound ACL going in. So that's all we have to do. So let's go do it on R1, and we'll do that right here. Okay, so here we go. Hit enter a couple times. All right, we're in R1, and we'll do a conf T. It gets us to global config mode, IP tab access list extended, and this is going to be the outbound _ ACL first. All right, so we do that, and now we're in named access list mode, and now we put in our statements. Permit ICMP any, so any source, any destination, enter. Then permit TCP any source, any destination. We're not going to specify a specific TCP port, but we're going to allow all through as long as they've been initiated from inside the network. And we'll reflect, and we'll call this TCP-traffic. That'll be our reflexive ACL name. It's going to open up a temporary access control entry, or ACE. All right, and then we'll do that. Then we will say permit UDP any equal to port 53, which is DNS. We'll call that DNS-traffic, and then we're going to set a timeout. It's going to go off screen here, so let's see here, time out space 10, and then we'll hit enter. Okay, and it says that I forgot the reflect keyword after the 53. Notice it said invalid input. It tells me exactly where I have my problem, so I'll just do an up arrow, and I'll arrow over. Got to get that reflect statement in there to make that work. All right, then hit enter. All right, and we're good. So we have our first ACL written. I'm going to just do a Control C to get out of that mode, and then I'll go back into that mode by typing conf T, configure terminal. And now we need to do our second access list for our inbound. So IP access list, it's going to be an extended. We're going to call it inbound underscore ACL. So this will be our inbound ACL. And we will permit, coming back in, ICMP any space any. All right, that looks good. And then we have to just evaluate the outbound reflexive ACLs that we created. So we say evaluate TCP-traffic and evaluate DNS-traffic. All right. Okay, that looks good. So set that up. We have our two access lists. And now what we're going to do is we'll do Control C and then a conf T, configure terminal, to get back to global config mode. And now we need to apply them. So we'll go to our interface serial 0/0/0. Whoops. All right. Now we're in interface configuration mode and time to apply them. So IP access dash group, and we'll say outbound underscore ACL out. And then I'll do an up arrow and I'll set the inbound. So in, and change this to inbound. All right, boom. Okay, so we've set that up, and we'll do a Control C and a show run. All right. And you can see that now we have the inbound ACL inbound and the outbound ACL outbound, and those have been set up on the serial 000 interface, which is the correct interface. It's this interface right here. So outbound and then inbound. Okay, and let's see. We've just been given a hint, but I'm not going to say anything till I demonstrate it. But let's see now on our access list. We'll hit more. We permitted outbound ICMP to any source to any destination, and we permitted ICMP any source any destination on the inbound. So we should still be able to ping from PCA to PCC, and we'll give it a test. So we'll run the test, run an up arrow here, ping 192.168.3.100, and we'll hit enter, and you can see that the host is unreachable, right? And I've done this before, so I've already troubleshot this, but it was pretty infuriating the first time. Well, how is that? How come we can no longer ping? Well, we know that the only thing that we've done is add an ACL to our router access list, 2 ACLs, and it has closed off the ability to use ICMP across the network, right? So our access list has shut down ping. But what needs troubleshooting is when we look at our ACL, it says that we've permitted both ICMP inbound and outbound. So why is that? So this is a good troubleshooting scenario, well, and the reason is, some of you may already have figured it out. The problem is that we've lost the route to the 3 network. We no longer have a route to the 3 network, and I'll explain why. Well, we'll do a show IP route, which will look at our routing table, and in our routing table, before we had 4 networks. We had learned 2 networks from EIGRP, and now we just have our 2 connected networks in our routing table. So we've lost our EIGRP routes, and so what's happened is our firewall has blocked the EIGRP routing protocol from communicating from router to router, or at least to this router. So R1 can no longer basically send EIGRP packets to R2. and it probably can't receive them either, because on every access list that you apply on your interface, at the end of the access list is an implicit deny all. So if you haven't permitted it, then that traffic's not going to be allowed through. So the question is, how do we allow EIGRP through our firewall? Well, it's actually pretty easy. So to allow EIGRP through our firewall, what we have to do is go to global config mode, and we have to go back into our access list and add the statements. So we'll say IP access dash list extended outbound underscore ACL, get us back into our named access list. And if we just put another permit statement here, it'll append to the end of our access list, and that should be good enough. So what we're going to do is EIGRP actually operates at the IP level of the OSI model. So it's an IP protocol that it uses on port 88, but you can't access that from the access list. So what you're going to have to do is do a permit space, put a question mark, and you can see EIGRP is a choice right after the permit statement. So we can just say permit EIGRP any source to any destination, and we'll hit enter, and that allows the outbound EIGRP. Now what we'll do is we'll do a conf t, and we'll do IP access list extended, and then we'll do the inbound ACL, and we'll add the same statement, permit EIGRP any source, any destination. All right. So now, if we do a show run, oh, and look what just happened. This is interesting. You can see right from the output, from the messaging, right from the router, that the dual algorithm has now established a neighbor relationship, an adjacency, right, with the other router. So EIGRP is now able to function again. So that works. So you can see that now, if we do a show IP route, we can now see our two EIGRP learned networks, and now our client should be able to ping across the network. And it can. So we've solved that huge problem. Now the other problem is to see, or not a problem, but to see if we can reach our web server. We were able to do it before. Let's see if we can still do it. So we'll refresh this window, and you can see that we still have access to the web server, and that's good. Let's do a fresh window just in case. And we'll say 10.2.2.1, and there's the connect. So we've connected, and we'll put in the password class. And being able to reach the web server is proof that our reflexive ACL is working. So now we have proof that both our ICMP, which should have worked both directions regardless, is now working, and we have TCP outbound. Since it was initiated from inside the network, we are able to receive the web page, so we know that's working. Now I don't have any DNS servers set up on this NetLab, so we're not going to test DNS, but I will point out that we had to add a permit EIGRP any to get it working, and I put that on both the outbound and on the inbound. So there's an example of reflexive ACL, and I hope that was instructive and helped you out.